Hello everyone, today we are going to speak about an important concept in using Grasshopper, which is Attractor point, and it can have different applications in architecture and urban design. So we will start with a boundary. Let's say we want to have this curve, and I'm going to use the curve component and set one curve, and I want to have a number of points inside this boundary. Then I want to make changes based on a distance from a certain point that I will define. So first I'm going to use a Populate 2D, and I'm going to use this curve as the boundary or region, and I can define how many points I want to have inside this boundary. Let's say I want to have 80. And I can use a seed to change the placement of these points. So let's say I want to have a slider of 123, and by changing this number, changing this slider, I can have different placements of the points. Then I can use these points and use the circle component, which is also inside the curve and inside the primitives. I can use these points, and the radius for it can be instead of having one slider to make all of them like the same as we see in here, I want to set them based on their distance from a certain point. And how I'm using it is by using Evaluate Surface, which we spoke about in the video of part 8 about surfaces. And you know that we should reparameterize the surface, and then we can use an empty slider and connect it to our UV surface. So it was better if I first use the surface and then connect it to here. So let's also use a custom preview to make this point more visible. Use a color swatch of black. And now we can have this point in our surface based on this changing in this MD slider. So I want this radius of the points to have a relationship between their distance from this point. And that's by using the component distance, which is inside the vector and inside the point subpart, and by connecting the points from Populate 2D to the A input and the point from Evaluate Surface to the B input, which also can be different. You can do it in another way. And now if I connect these distances to the radius, you can see that they're so big and they go outside of my boundary. So I need to use a remap, which is Remap Numbers, and we spoke about Remap Numbers in video part 6 about numerical sequences. And as you know, we should use a bounce in here and connect it to the source, and for the output, let's just disconnect this number, and for the output we can use a construct domain, and define our domain of these radiuses. Let's say we want to start from point 2 to number 2, for example. Okay. Now you can see that by changing the placement of this point, my points and my circles are becoming different, and I also can add to the number of our points, and also change the seed, and then you can see that they are different. But they're also outside my boundary. If I wanted it to be inside the boundary, the thing to do was to make a offset of my curve, offset curve, which is in here, and we could use this curve and take a domain like 2, the distance between these two curves. And as you see now, it's becoming outside of our boundary, but if we wanted it to make an offset inside, we need to flip curve. We spoke about flip curve in video part 3, so you can watch that if you need. So I'm connecting this curve, and now my offset would be as I ordered it to be. And I can also use my maximum of the domain of the circles based on this distance that I have in here, so that the circles are not going outside of my boundary. So I'm connecting this one, and as you see, I want these points to be generated inside this offset curve. So if I connect this one, you can see that now none of our circles are coming outside of the boundary. And by changing this, you can see the result. But just instead of using just a circle, we can have different options to have to see the importance of attractor points. And one of them is by using the pattern of Voronoi. So let's say we want to use this pattern and have a landscape design based on and have their extrusion of this pattern be based on their distance from this point. So I'm going to use these points from Populate 2D and taking this boundary as the region, as the boundary in here. And so now I have my pattern, and I want to make a boundary surface of this pattern. And as you see now, we have 161 trim surface, which are each of these parts. And I want to use extrusion, so I'm going to use extrude, and the Z value for these patterns for each of them, instead of having just one number, I want to make it based on their distance from this point. So I have this component distance, and I'm going to use a remapped form, but instead of having this construct domain, I'm going to create one. And so let's copy this remap and make a new construct domain, or also copy it from here, and set it to a minimum of like a 3, a maximum of, let's say, 20. So this is the maximum and minimum of my Z value for the extrusion, and I'm going to use it and connect it to the Z value. And let's also use a custom preview to make these cells more visible. And let's use a color swatch of maybe gray, and we can also add to the transparency of the color. So now you see that we have these cells, and their extrusion is based on their distance from this point, and by changing the placement of this point, we can have different designs. Also, instead of using this color swatch, we can use a gradient and make it also to change to have different colors based on the distance from the point. And we can change the preset. So let's say we want this color, and we want to have a T value, which is the remapped of these distances. And instead of using this construct domain, I'm going to just disconnect it and put it on the default of between 0 to 1, because this t value needs to be between 0 and 1. So if I connect it to the m value, you can see that based on the distance between these points and the point that we had in here, the extrusion height and also their color are different. Okay, so this was the first example. Another example can be in designing part of the city. Let's say we want to have a lot of buildings, and we want them to have a distance from a curve. So this was an idea of the distance between one point to other points. Now we want to have the distance from the points to the curve. So I'm going to just make them group and hide them, and use another scenario for my design. So I want to have a curve inside my design, and I'm going to bring it inside my Grasshopper screen using set1curve. And also I want to have a number of buildings in here, and for doing that I can use divide surface component. So first I'm going to make a surface as we had in here also, and I'm going to use divide surface so that I will get my center point for the buildings. And I can also change how many divisions I want to have in each of these parts, which is U and V directions. So let's put it on maybe 12 and 8. So now I want to use a rectangle and connect these points to the point value, and for the x and y value I want them to be to have a plan of a square. So I'm going to use a construct domain, and for both of them I will put it on 3. So because this rectangle works based on a center point and the domain for x and y value, so I need to put one of them on -x and the other would be on 3. So it makes each of them from -3 to 3. So the edge length is 6 now. And so I have my building plans, and I want them to have an extrusion. First, let's make a surface to make our extrusion solid, and a Z value. Okay, if I connect the number slider, you will see that all the buildings have the same height, but I wanted them to have a distance, to have a height based on their distance from this curve that we have in here. Let's say it's a river inside my site, my designing site. So for doing this, I'm going to make a curve closest point, which is inside the curve and inside the analysis tab, and I'm going to connect this curve to the curving point, and at these points that we have created in here would be the curves that we want to make their distance from this curve. Okay, this component takes us the points which are the perpendicular forms of the points that we had in here on the point on this curve, and also it gives us the distance, which is very important for us now. So I want to use these distances and remap them and use them as the value for the z factor for the extrusions. So let's use it. And using the bonds to take the source domain, and using the construct domain and let's say we want the minimum height of the buildings to be on 3 and the maximum would be on 12. You can also then change these numbers, there's no problem. And connect this result to the value for the z factor. Let's also hide these parts and use a custom preview. Okay, now you can see that the height of these buildings are based on their distance from this curve that we had in here. And we can also change this curve. Let's say we want to just move it inside different vectors, or also we can rotate it and see that how it how it changes these heights. Okay, let's also make a rule that if these points are very close to this curve, I want to these buildings to be just eliminated, because if it's a river, we do not want to build our buildings on top of the river, and it needs to have a distance from it. So for doing it, we need to add something inside in here. So we want to call indexes, or we want to use a call pattern and eliminate a number of these points. And so I'm using these points, and the pattern for eliminating them is based on the distance from the curve. Okay, so I have these distances, and I want to make a rule that if they are smaller than, we spoke about smaller than statement inside video of part 4 about the split list and separations. You can also watch it if you need. And let's say if the distance between the center point of these buildings from this curve is less than 5 meters, or we can also add to it, we want these points to be eliminated. Oh, sorry, I want to add this to the distance that we had in here. So I'm using these distances, and if they're less than this, if they're closer than 8 meters, for example, I want them to be eliminated. So I'm using this pattern to the P input, and this will be the new points that I have. Let's hide these buildings in here, and as you see, these are the points that are eliminated. So if I use the dispatch component and we also spoke about dispatch in video part 4. If I connect this dispatch and add the first list of points which we had in here, and take this pattern to it, you can see that these would be the points that are eliminated, and so these are the points that we need to keep because we want them to be the center point of our buildings. So I'm going to connect these points to the curve value, to the rectangle, and then we have these points. Just the problem is that we also need to use these new points, which a number of them are eliminated, and use this for the z value, because as you see here, and the number of the points that we had in here, their height is also added to this part, which is not what we wanted. And as you also seen here, we have 92 surfaces, but the z vector for it is 117, so we need to just change it in here. And again, take the distance from these new points. So I'm connecting this one to the curve, and I'm connecting these parts to this new remap surface. So this is the values, this is the bounds, and now it's correct. Now we can see that again, by changing this curve that we had in here, we can have different design of our settlement. Another way that we could do this is that instead of just making the height of these buildings, we make the topography of the place, and then all the buildings had the same height, but because of being on the top of the topography or in these parts, they would have different views to the river. So let's do that. I'm going to hide in this part. And I'm going to use these points that we had in here and move them inside the based on this z value. So using these points, using this z value, and I'm also using the curve closest point that we had in here, and I'm going to use a remap. I'm going to use a remap numbers and move these points based on the distance from this curve. Okay, using the bounds from this to find the source of this domain, and let's say our domain, construct domain, will be from 0 to 20. Okay, now this is the new placement of our curves, of our points. And if I hide these points, you can see the points that now we have. And also I can use a surface from points component, and we spoke about this component inside the part of the surfaces, so you can also watch that video if you need. And if I connect this U value that we had in here, and also flatten the points as we discussed there, and also make an expression of x plus 1, we can have our topography of which uses these points. So we have the points, and just make this elimination or removing the points that are very close to the curve in here, and use this set of points instead of using those. So I'm going to do the same. So I'm going to make a distance, or also curve closest point. I'm taking the distance from these points to the curve that we have. So let's also name it a river and make it more visible inside our code. And let's change the color of the grouping for it to something more visible. And now we have these distances, and we just need to dispatch them. Dispatch these points based on their distance from the curve. So if this distance is larger than, so instead of smaller than that we used in here, I'm going to use a larger than, and I'm going to say if it's larger than 7, it's okay, and keep it. If not, just eliminate the point. So now you can see that these are the points that I will keep. And now I want to make a surface. I want to make a cube and create my building on it. So because the building needs to have a foundation, first I'm going to move it in the direction of Z, and just make an expression of -x, because I want it to be negatively moved. I want to make it closer to the ground, and put it on 2, and then create the rectangle as we had before. So just copy the rectangle and use these points. Okay, and then we use the surface component and also extrusion. Now we can just use the Z factor of 3, that every building just has a height of 3, but because being on the topography, they have different views to the river. And now let's hide everything and use a custom preview. Okay, now as you see, we also can group our topography and make it also different from all the other components that we have. Also, let's use a custom preview to make it visible inside our Rhino screen, using the color swatch, and maybe put it on green. Okay, now we have our settlement or our village maybe, which is based on this distance from the river that we have in here. We can also change these numbers that we had for the first curve, for the first surface, and let's make it a little different. We can also change this number, which was the distance from the points to the curve, and eliminate more buildings. Also, we can change their direction. So because now all of them are just in XY, but if we wanted to just rotate these buildings, we could use a rotation and put it on degrees, and the plane for them would be the points that we had in here, which is the center points of these buildings. And let's connect this one. Okay, for the degree, I want to also put it based on the distance from this river. So again, I'm going to use a map, which is in here, and making a new domain, and put it from 0 to maybe 90 degrees. I'm connecting the result to the angle. Oh, we have a problem in here. Let's see what it is. We have 58 objects and a 58 plane, but the angles are 70, and that's because we eliminated a part of them in here, so we cannot use this remapped. It was from the first list that we had in here. So I'm going to make a curve closest point again in here, so from this point to this curve. So it's very important that the number of the data that you are using together would match together. If not, it just makes your definition to not work properly. So I'm going to use this one, and as you see here, again I have 58 distance values, which is correct because also these were 58 values. So now I'm going to use a remap in here, again using the bounds, and also the construct domain, and put it from 0 to 90 as we spoke about. And let's connect these results to the angles. Okay, now it's working correctly, and we can also change it to make it more rotation domain or less. And also, instead of the distance from this curve, maybe we could have a point and say, let's say we have a square in here or a monument, and we want to change it based on that point. So instead of a curve, we could also use that. So for using that, we also could just using the evaluate surface as we had in the upper example in here. So again, using reparametrizing this surface, I'm using the MD slider. Let's just disconnect this one. So we have our point on the surface. We have one point, and I'm going to get the distance from this point to these points that we have in here, and use this data as the remapped. So as you see, by changing this point, the rotation will be different. So this was the second example about designing on a valley. And the last example for using attraction point would be for designing the facade. So I'm going to rotate it, and this is its facade, and I want to have a pattern for my facade, and make the pattern to work, for example, based on the light. So I'm going to bring this curve to my Grasshopper screen, and I can make different patterns on it using the component LunchBox. And inside the panels you can see different patterns that it has. Let's say we want to use a hexagonal cells, and if we connect the surface, so I'm going to use a surface inside in here, and if I connect the surface to the surface input, and by changing the U and V values, because now it's on 10 for both of them, but let's put it on 6 for the U, and maybe 4 for the V, and also we can change it later. So this would be our cells, as you see in here. Okay, if I want to have them as my windows or pattern on the facade, and work based on the light, so I can use these frames that we have in here, the panel frame, and I can use these curves that I have as the panels. And the S factor, which is the scale of this. So if I put it on, if I change the slider, you can see that we can have different options, from having it very small to make it more big. Also, if I can use a custom preview, it would be more clear which parts are the frames. Using a color swatch of black, I'm using the color swatch of black, as you see in here. So these parts are the frames, and I can change the scale for them. So instead of using this number slider, I can again make them based on points and attractor points. So again, let's say we have an evaluate surface, we parameterize it, and using an empty slider, and let's use the distance from these centers to this point that we have in here, and using the remap numbers, we want to use these distances as the scale factor for our frames. So I'm going to use a bounce like what we had in the upper parts, and a construct domain for our target, and let's put it on 0.2, and the biggest on 1 as it's in the default. So if I connect the result to the S factor, you can see that based on their distance from this point, they will have different scale factors. You can also make it in a different boundary of in a different domain. So everything can be changed, and we can have different designs. We can also add to the U value and V value. Or also changing the panel. So that brings us to the end of this lesson. I hope you enjoyed it, and we will continue in the next videos.